In this video tutorial, control structures in LabVIEW will be explained. Control structures include the for loop, the while loop, and the case structure. In this tutorial, I'll demonstrate the for loop. In programming, the loop structure is used when a set of instructions need to be executed repeatedly. To demonstrate the loop, a LabVIEW VI will be created to compute and display the factorial of a number. In the block diagram, we need to get the for structure. Right-click, expand the window, go to Programming, and within the structure library, choose the for loop. Expand and open the for loop. This is the count terminal, which determines how many times the for loop. While I is the iteration terminal or the counter of the loop, and the value of I always starts from 0. The value of I is automatically incremented by 1. To create the block diagram code of the factorial problem, it would be helpful to see the algorithm written here in C++. The first thing in the algorithm is to input the number. In LabVIEW, we can do that by connecting the N terminal with the control object. In the block diagram, we come to the N terminal here, the outer side of the N terminal, and we need to connect to this a control object. Right-click, create control, and we can label this as N for the input number. Notice here in the algorithm, the counter of the for loop I starts at 1. So if we come to the block diagram, within the for loop we need to update the value of I, or increment the value of I by 1 so that I starts from 1 and not 0. We can do that by getting the increment function. Right-click, arithmetic and comparison, numeric, and here we have the increment function. So we connect the I terminal with the increment. Now our I, the counter starts at 1. Notice here in the C++ algorithm, within the for loop, the factorial is computed iteratively, meaning that factorial equals factorial times I. So if we go to the block diagram, we need to get the multiply function. The output of the increment function is now connected to one input terminal of the multiply. Now we will take the output of the multiply, which represents the factorial, and make a feedback to the input. Notice here we have the initializer terminal, where we know that before the loop starts, the value of the factorial, the initial value of the factorial should be 1. We can do that by right-click, and we create a constant with an initial value of 1. In the front panel, we need to add a indicator object to display the value of the factorial. Right-click, number indicator. We'll label this as factorial. Now in the block diagram, we need to connect the output of the multiply function to the factorial function indicator. So we will wire the output from here into the factorial function. Notice that we have an error here. Now if we check the list of errors here by clicking on this broken arrow, we will see that it says block diagram errors. You have connected two terminals of different types. This error means that the tunnel created here is an auto-indexed tunnel that passes an array of n values but our indicator function here is designed to display a single value. Thus, we need to disable the auto index tunnel. So if we come to the tunnel here, right click, and we choose disable indexing. Notice now the error disappears and the tunnel becomes filled tunnel, meaning that this tunnel will pass single value, which would be the last value of the loop, and in this case it would be the factorial value, and then displayed on the factorial indicator function. Now let's test the code by finding the factorial of 4, for example. You can see that the result is 24. If we change the value, let's say the factorial of 5, and we get 120, factorial of 6, 720. The next loop structure I want to demonstrate is the while loop, which loops indefinitely until a condition is satisfied. In the block diagram, to get the while loop, we need to right click. Within the Express library, we go to Control Structures, and then we select the while loop, and then we open up the while loop. The while has two terminals, the loop iteration and the loop condition. The loop condition is controlled by this stop function. The while will only stop when this function gives a Boolean true value. Let's say we want to display the value of I via this numeric indicator. As in the for loop, the value of I starts from 0. To slow down the loop, we can use the wait function, which will pause the loop at each value of I by milliseconds. To get the wait function, right click, we expand the window, programming, timing, and here we have the wait function. On the left hand side of the wait function, we can connect a constant to slow down the iteration in millisecond. Right click, create constant. Let's say we want to slow down by 1 second, so it's 1000 milliseconds. In the front panel, we execute the program and observe the output. As you can see, the iteration started at 0 and it increases by 1. And this continues indefinitely until the user presses the stop button, which then initiates a true value to stop the while loop. We can also control the while loop via a condition within the loop. For example, here the while loop stops when the iteration exceeds 8. Running the program, we observe that the iteration starts and it will stop when the value of I exceeds 8. This concludes this video tutorial.